Hi everyone, this is Mario here, and today we are working on a problem, and it says that a chemist wishes to detect an impurity in a certain compound that she is making. There is a test that detects an impurity with probability 0.9, which is 90%. However, this test indicates that an impurity is there when it is not about 5% of the time. The chemist produces compounds with impurity about 20% of the time. That is, 80% do not have the impurity. A compound is selected at random from the chemist's output. The test indicates that an impurity is present. What is the conditional probability that the compound actually has an impurity? So, remember, this is the type of, I want you to understand sometimes that when you find all these things, the first thing, try to do a tree diagram. If you can't do a tree diagram, or if it doesn't make sense, then do it a different way. But the first thing we're going to do here is a tree diagram. So here we have the test, okay? We have test, T, test. It says that this test can have an impurity or it doesn't. So impurity and impurity not, which is the complement. It says that if it has an impurity, it finds it about 90% of the time. So if it's positive, then 0.9 they will find it. So that means when it's negative, it's going to be 0.1. Now it says that if it doesn't have, when it doesn't have an impurity, it says it's positive about 5%, so 0.05% of the time. So when it's not, when it's negative, then it's 0.95. Then it says that the chemist produces compounds with impurity about 20% of the time. So about 20% of the time, that means it has an impurity, which is 0.2. So 80% do not have impurity, so 0.8. Now we can work on the problem, because it says, what is the conditional probability that the compound actually has an impurity? So basically asking you, probability that given the test indicates that impurity is present. So let's say present for positive. So the impurity is present. Find the conditional probability that the compound actually has an impurity. So find I positive. Now, that would be equal to the probability that I is positive intersection positive over probability of positive. That would equal to, when I'm going to do that one in red, when I is positive, so this is I, and that's when it's positive, so it's going to be equal to 0.2 times 0.9 over, because it's only here positive, so it would include this positive 0.2 times 0.9 plus here also is positive, so it's going to be 0.5 times 0.8, so 0.8 times 0.05. And this, let me do it quickly. So 0.2 times 0.9 plus 0.8 times 0.05, that would equal to, now let me do this one first, that would equal to 0.18 over 0.22. which is equal to 0.818. So this is the example. That's what it is. So understand that sometimes when you have those type of problems, think of the tree diagram first before you do anything else, because that's the best approach to solve this type of problem. So I hope you enjoyed and understood the problem, and if you like it, thumbs up. If you don't, thumbs down. And actually, if you want to subscribe, that's fine too, because um, it should be great. But apart of that, that's actually about it. So enjoy.